So, as discussed in class earlier, time ran kind of short on us. App development for Android in 8 weeks is awful compressed anyway, and I don't want to fall behind schedule. There's a certain amount we want to cover. So, I'm going to fill out that example we rushed through in class this evening with the full lecture here on a video. Hopefully this will all make sense because working with data is a very important aspect. We want our data to persist sometimes between different times running the app, and not just the shared preferences or map to an intent like we've seen. We want our data to hang out in a more standard format. So to do that, every Android device has SQLite database capabilities worked in, or SQLite, as some people like to say. Let's take a look at that web page real quick, and then we'll talk about that just to make sure that's what's going on with that is clear. And whenever we set up an app to work with in Android Studio, it's ready to go. All the libraries for SQLite are imported, ready to go for us, built in. So let's take a look at that real quick. We can find it pretty quick. Just go to Google and search for SQLite. And this is something that's available in a lot of languages. It's not just an Android thing. So here on their home page, we can see the important part. It's wrote in C, but well, I'll read right from here. Small, fast, self-contained, highly reliable, fully featured SQL database engine. That's kind of basically everything we want a database to do. And the other important part of it here, SQLite is stable, cross-platform, and backward compatible, and the developers have all promised to keep it that way at least through 2050. So it's stable, reliable, has all the features we'll need. It's going to be compatible for many years yet to come. It's a good little library to work with. And it'll look familiar if you've worked with any SQL things before. The setting up our queries and all of that should look familiar. So let's go back to the board and discuss the plan for our little example app here to work with a SQLite database. So that's the type of database we'll be working with for this evening's example. This is just a quick example project. Hopefully it's enough to kind of see where to put things, some of the pre-built methods, get a start. We're doing Android in 8 weeks, so it's kind of a start of everything. So for a simple example, our database what I had in mind is just a simple table with a couple of values. Obviously an ID field, just by the nature of relational databases, we need a unique identifier, primary key, all of that. We'll go ahead and do that. So what's kind of become my standard example, just a simple one, put in a name, age, and town. Data, just some simple data to work with. Might as well put types up here. ID, that'll be integer. And let's see, can I draw a little key here? Little key symbol. So that's going to be our primary key. Hopefully that's visible in the video. Name, obviously a string, which for SQLite You're maybe used to working with MySQL or SQL Server, and we have Guard and a whole lot of different types. But with the light part, we just have the one thing. So that'll be a text in the database. Again, age, we usually give those as integers. And the town, obviously a town is going to be a text. We're not going to use zip codes or anything. So that's kind of our sample data to work with. We have a unique primary key identifier, text for a name, integer for an age, and text for a town. And those are the fields we'll work with. Getting over to the Android side, that'll be a database that's built into the database we'll use. And SQLite is built into every Android device, so we can use those consistently. I guess we can start with the layout. So what I had in mind for this app is a couple buttons, maybe a couple text fields, and a couple buttons. So up at the top, we can put a couple of text fields for the name, the age, and the town. Just a couple buttons here. Obviously an add button, that's what the text fields views go for. The edit text, we'll have those, fill those in, click add, put the data in our database. I'm going to go ahead and put in a button to remove all, something that just deletes all the data out of our database, for example, thing. And then the rest of our layout, user interface, is just going to be a big list view. We'll inflate a list. We'll inflate a list of items representing what's in the database. So obviously we're going to make a Java object to organize the data. Or it's a good idea to. That way we work with one array of those objects instead of a bunch of different arrays. Instead of 4 different arrays and trying to line those back up, we can have one Java object that has 2 integer fields and 2 string fields, and put our data from the database into that Java object and work with just a single array or list or whatever data structure to get those onto the screen through processing and stuff. So we'll have that, and we'll throw it up in a little layout that just has a few text views, ID, name, and age really big, and town somewhere on there. We'll put something together when we get over to Android Studio. We'll do that, and inflate that layout out into our list view, so we'll need an adapter. Guess I should write the Java object in here. I'll do a little class diagram, I guess we can call it DB item. It's going to have int, string, represent all that stuff. The constructors, getters, and setters, it's just an organizational object, so we don't need custom methods. Just a couple constructors, some getters, and setters will work for that, and to organize our data. Feed that into a layout, and put that layout into a list view, and that'll represent our activity. And what else do we need? So after we do that, then we'll need our database item, 2 layouts. The layout we're going to inflate, our main activity layout, and then in our main activity we can kind of work with this stuff and the adapter to fill it out. So we have a few objects that we need to make, and then with our once we get that made, our main activity can work with the data in the database, which is a standard form of holding data. A relational database is in a format we can use with other software or other databases in general, and just have our data persisting from run to run of the app without using shared preferences or mapping to an intent where we just keep it bouncing around memory. Not the best way to work with data. We need it in storage somewhere. So why don't we jump over to Android Studio and kind of get started making these objects. This is just an organizational one. That should be fairly straightforward. Layouts, we've done those a couple times. Adapters we've seen. So we'll get those together and then we'll get started into the SQLite database part. So let's jump over to Android Studio and do that. I'm just going to scrap that one we started in class and kind of rush through and work all the way through this. So starting a new Android Studio project here. Like normal, just an empty activity. That's a good place for it. The class folder. And I'm going to call this database example. Using Java. That's probably good for the class. When you get ready to sell stuff, I think the week after next, I've already paid the $25 fee to put stuff on Google Play. So we'll kind of walk through my account and see where all the buttons and load and storage and options are on there. But when you're ready to make your own, you might want to look into seeing, put a little more thought into it, but any of them will work for introduction class. So we'll let that generate. I think, and there's no need to watch the Gradle build run here. So I'll pause the video and be back in just a second. That with the Gradle build and getting everything set up for us, we can go ahead and get started here. So I'm going to go ahead and start with the layouts. Well, like we saw on the board, the plan a moment ago, there's going to be 2 buttons and 3 text boxes we'll probably need some string resources for, so I'll start there. We've seen this quite a few times, just setting up the string resource as XML data. So name, I guess we'll have a button add, and that'll say add data, and then a button that empties all the data. Remove, and that's going to say remove all data. And then along with the remove all button, we'll set it up so that when we click on an item in our list view, it'll delete that item from the database. And we'll also have 3 edit text to enter information into to go with the add data button. So we'll set up some strings to go in those. And make sure when you use an edit text, they use the hint property and not put text in it. That way the user doesn't have to delete a bunch of letters or words just so they can start typing. You want to make sure you use the hint one. So what do we have? A name, hint. I'll just say name, string name equals equals txt age hint, say age, and then a string resource for text town hint. And then that one that I like to put in there, just a string resource for an empty, which obviously would be quicker just to leave that box blank, but I found that can be very helpful when debugging, because then when we're looking to trying to look at everything in as quick as possible, when we look at the text field, we see a annotation to a string resource, which is what we would expect to see there. We don't have to stop and think about it. I've just found that's useful for debugging, to go ahead and save the empty string as a resource as well. It looks right when you're glancing at everything. And once again, make sure you use the hint property on the edit text. That way there's nothing in the box, so when the user's ready to start typing, they just click on the box and can start typing. And the hints are the grayed out text. So that's the string resources we'll need. And we can come over to the main activity and set that up first. Get rid of this little text view here. So for tonight's example, a linear layout will probably work. We'll put a row of text, edit text to enter data, the buttons that are empty the database, and then a list view to inflate. So bring that in. And since that's sitting in a constraint view, I like to go ahead and hit these buttons. Whoops, undo that. And just go ahead and constrain it everywhere, which is probably unnecessary because I'm going to come over here and make sure that this says match parent. You always want to check that when you're inflating the views to put here, because sometimes the Android device will go with the size, and if it's taller than the screen it's showing on or wider, it won't bring up the scroll view. It won't bring up the scroll bars because it thinks it's everything's showing, but it's just looking at the numbers, which might be bigger than the screen. And I'm going to go ahead and change this view to a tablet. I'll be previewing this on my 1280 by 800 tablet. That way we at least have some general idea of what it is. So the top row, I'm going to bring in as another linear layout, but a horizontal one this time. And in that, I want to bring in 3 edit text. So a plain text. Did it right again. There it goes. Set to wrap content. This one's going to need a name, so this is going to be txt name. And right now, it starts with this text property in here, but the user would have to come in and erase that before they went to type anything. So we don't want any text there, so that's going to be at string, the empty string. And again, I just like to do it that way, so if I'm looking for a problem, when I glance at that box, I see an annotation for a string resource, so it's what I expect to see there. Then we use the hint property, which is the little grayed out text that just kind of disappears as soon as the user starts typing. Set that for the width and height. That looks good. So then we need an age text box, and that's just going to be a number. So we don't need to see the whole keyboard. We can bring that down, the number edit text, which is just, it's still a text when we get to the Java, but there's a bunch of things preset in it to work with numbers, not with text. So text age. Once again, we want to use the text property, so at string age hint. And the text on here, well, that one comes as empty, but I'm going to go ahead and set this for the same reason. That way, when I glance at that box, I see what I expect to see in it. If there's a problem that needs to be tracked down. And then a town was our last bit of data, so bring down another text view, or not text view, and edit text. txt town. Put in the little grayed out text that'll go away as soon as the user starts typing instead of some actual text there. And put an empty string for the actual text. And that kind of wrapped that nicely. We can see though, here if we click back on the linear layout, well, the width is set to match parent, so it's going to be as wide as the thing. So that's good. But right now the height is set for the whole height, and we don't need that. So we can switch the height to just wrap content. That way it's only going to be as tall as those text boxes, and we can bring another one in for a row of buttons underneath that. Drag in a button here. And if you start nesting these like this and end up with something in the wrong spot, it's best to work with the component tree view here, because then you can drag it up and put it in different, you can see the little blue line there, and place it in different containers. It's a little easier to adjust than trying to drag them around here and hope it lands in the right spot. So first one, button add, and this will have actual text on it. So add string button add. Then we can bring in another button. Called button remove. And same thing for the text that shows on it. You can see these layouts are kind of nice for filling up the space nicely, organizing things. And again, match parent's good. We want it to be the right width. We want it to match whatever screen it's on. But for the height, we just want to wrap the content. We don't need anything past those buttons. Then all this space down here, we'll bring in the list view. Or maybe it's under containers. Recycle view is a newer version that's very similar. Almost identical, basically. I'm just going to use a list view because we've seen those, and that's what is in the textbook, so your immediate reference material goes to that. And this just needs an ID so we can refer to it. I'll call it display data. Hopefully I'll remember that name. So that is our layout for the main activity. Some edit text to put new data in with a button to add it, and a button to clear all the data. Then a list view that will inflate our onto, and when we'll set it up so that when we click on an item in the list, it'll automatically delete it from the database. And so I guess the next thing is we need the little layouts we're going to inflate here. But I need to render this video down, and then I'll be right back to do that. For the data we're going to inflate for the list, we'll need a layout for each item we want to do. So if we come over here and right click on layout, under new, layout resource file. I'll call this can't have capital letters, DB item layout. And I like to work with constraint layouts, so I'm going to set the root element to constraint, the Android X.constraint layout, widget.constraint layout, all of that. We don't need any modifiers, those usually come later. We make a default version, And then we make all the versions for like different screens and orientations, density, all that different stuff we do to copies of once we get everything working, typically. That way you don't have to go through and change every file if anything changes along the way. So this is just a basic layout XML file, and I like to use constraint layouts. If you want to work with something else, that's fine. Just work with whichever one you prefer. So if you remember from the board stuff a moment ago, our table had 4 fields. Had a unique identifier, the ID, a name field, an age field, and a town field. Or if you've seen me go over database stuff in another class, you've probably seen the same table. So we just need 4 text views to see that stuff, basically. So I'll start bringing those in. I'll go ahead and constrain this one up in the corner somewhere. Bring it down a little, add just a little bit of padding. And that's probably kind of small. So this will be the text ID. Hopefully I'll remember I capitalized that D there. The text is going to be overwritten whenever we inflate our data into the list view. One thing I'm thinking about is the size. We probably want these different fields to show in different sizes. So I'm going to scroll way down here under all attributes and go to text size, which as always should be set up as an XML resource, but as we see over here, the dimension folder isn't there. Dimension file isn't there by default. So I pointed out before, I like to just use the dialog box to create the folders and files and make sure everything's named correctly. Let Android Studio do that. So I'll create the first one, usually create the first one there, and then just type in the file after that. So clicking the little button over at the right brings up the dialog box, a new resource, new dimension value. I'll call this txt id. Oh wait, ID text size. That'll work for a name for it. And what's a good size? The ID doesn't need to be very big. I'll do that. 16 sips. I think I worked with dips last time. We'll do sips this time. We have lots of different ways to measure things. So I'll do 16 scalable pixels. That way it adjusts automatically for different densities, different pixel densities. So now that we have the file created and named correctly and placed in the right spot, I'll go in here and make up a couple more for each one of our fields. So we had 4 fields. Name equals name text size. Oh, the name should probably be really big. I'll do that as 43 sips. A size for our age text size. I don't know, that can be up there somewhere around that. 37 sips, probably work. Mention name equals town text size. That one can be a little smaller, 24 sips. That'll give us some sizes to work with. So back in the DB item layout, I'm going to set this. So that's the set to the text size. So I'm bringing one for a text view for the name. And I'm going to constrain it to the previous one. That way the tops line up. And I'll just put it to the left side of that. Give it a little bit of padding. That'll be txt name. Then way down here, set that text size we prepared for it. So that's going to be add dimensions / name text size. Nice big name shown. And one for the age. Kind of do the same thing. Constrain it to the top here. That way our tops line up all the way across. Give it a little bit of padding. Something like that will probably work. And needs an ID, txt age, and apply that size. So use the annotation to refer to it, add dimension / age text size. They're going to move down. That way the tops line up. And then a text view for the town. I'll just bring this down to the bottom, and this time I'll line the left edge up with the name. That way there's still some alignment. Txt town, and again the text size. So add dimension / town text size. So that'll give the layout for our data to inflate into. So we'll inflate a whole bunch of those into this list, and we'll be able to add more or delete all of them, and at the end we'll set it up so that when we click on one of them, it'll delete it from the database. Now everything else we'll be doing in Java. So I'm going to go ahead and close these XML files. So our main activity, we'll get to that in a little while. I guess I could go ahead and close it. Kind of clear up some space here. A good place to start might be that custom object just to organize our data. Remember, we have 4 fields in our database, so we could just set it up to work with 4 different arrays, keeping track of each one, or a 4-dimensional array. What I like to do is make a custom object to organize it, and then work with a single array or list or stack or whatever type of data structure we want to work with, a single one of those objects. So we don't want to import anything, so if we right click on the package, a new Java class, those organizational objects are probably a good place to start. I was trying to type the word item and say object at the same time, and that just wasn't working. It's just organizational, so we don't need anything special there, just a name for it. And here we want some data fields to match our database. So we have a private int called ID, and we won't get there tonight, but there are some built-in methods that would kind of expect and look for a field called _ID. So we might as well go ahead and use that. That's kind of a convention if the database is handling an integer primary key, just call it _ID. There's some higher level things, which we unfortunately won't have time for in this class, that will look for that. So you might see it in some reference material while you're building apps later. We also have a string called name, a private int called age, oops, we can do that in lowercase, and a private string for a town. So we'll just pass in somebody's name, their age, and the town they live in. And this is just organizational, so we don't need anything fancy here. Just alt insert, put in some constructors, put in the empty constructor, alt insert, put in the full constructor, select everything, and probably one more, since we're working with a database, put in a constructor that has everything except the ID. So the database is going to handle the ID part. So this constructor is for objects coming back from the database, and this constructor is for objects going from our code to the database. So we usually need both if we're working on databases. And after that, we just need to generate all our getters and setters. And go ahead and select all those. That way we have them there. Probably be a good idea to delete the database is handling that. We don't want to we don't even want to have a way that we could accidentally change that. Otherwise, all the regular getters and setters. And that's just a way to organize our data. So the next thing is an adapter. I'm going to go ahead and render down this video and then start a new one to review the adapter stuff, which we've seen before. The next thing we'll need is an adapter so that we can inflate this data and the list and our layout for this data into that list view. So we saw this last week. Come over here, create a new Java class. I'll call it DB adapter. And this needs to extend base adapter. Be a subclass of base adapter. There it is. Android.widget.base adapter. We don't need any of the others for now, so just some subclass of base adapter. And we saw this last week, but we'll kind of go through it again just to review it. It's something that shows up a lot. Recycler views and grid views and lots of other things use this extend base adapter. So use the same classes. So what we need is a layout inflator, private layout inflator. Oops, layout inflator. I think I mentioned it, I might have forgot. I rarely use this notation. A common notation you'll see might be M layout inflator. That stands for member of layout inflator class. So the M is member of the class. That's a common notation you'll see in a lot of the reference material. I can't remember if I mentioned that or not. I rarely use that particular notation. I mostly stick with Hungarian notation for things on the screen, the 2 to 4 letter prefix, and then a meaningful name, and the Java standard naming conventions, camel case spelled out for variables, Pascal case on objects, all caps and underscores for constants. We've seen those a few times. But I wanted to make sure I mentioned that at least once. You'll see it in a lot of reference material. One of the standard naming conventions is also M for member of layout inflator class. So I'll go ahead and use that here. And we created this DB item specifically to organize our data. And that way we can just use a single array of that rather than a bunch of separate arrays and tie them back together later. So we'll need an array of DB items, however many we bring back from the database. DB, I'll just take the default name there. The standard Java naming convention for variables, the camel case. And on these we need a constructor. We looked at it last week. If we go to try to generate one, we have options to bring in a layout inflator or the database items array. So we can take the second one, and the layout inflator, those are always the same. We don't really pass those in. But we also, in order to instantiate a layout inflator, we need the context that it's inflating into. So we also need a context object. And I always like to put a C here instead of spelling out the word context, because we're going to call a static variable up from context. So if we spelled it context, we'd have a one with a lowercase c and one with an uppercase c in the same line of code. It can get a little confusing. So this dot member layout inflator class, we always instantiate these the same way. So what we're going to do is layout inflator. Cast as a layout inflator. The context we're passed in, get system service, and we want context dot layout inflator service. So the instantiating that will always look like this. We've seen this a few times where we get something from the operating system and just cast it into the object we want. It's a fairly common thing in Android to instantiate objects that way. And now we can see up here this message we've seen a few times. We either need to make this abstract or implement some methods. So we can come down here and implement all the methods, which is the required overrides. There's 4 required ones, so obviously we want all 4 of them. Count is how many things show on the screen. dbItems.length, we'll just do that, the length of the array. If it gets to be really, really long, you might want to split it up like you've probably seen many times in different software, especially on the internet. There's like 25 on a page, and then the next button or buttons to navigate between the pages. And probably switch those out with fragments or something. Y'all have seen all the pieces to put those together. This next method, get the item, so that's as it walks through our array, this one's going to be called in the background over and over again, so we just want to return that item from the array. This next method, it needs an index for Android to refer to that item by, so we can just return that index and it'll run it through an algorithm and produce the actual index it's going to refer to it by. Most of our stuff is going to happen down here. Sorry, just a little bit of editing needed done there. Where was I? Most of our stuff is going to happen down in this get view method. We want to return a view. What's a good name for it? List items. And we get that from our member of the layout inflator class dot inflate and the layout we want to inflate, which we have in our resources. So to get to the resources file, we can use the capital R, which is the indexed versions, which is similar to why we needed this method, the indexed versions of all of our resources. So r.layout.dbItemLayout. And for the second parameter, we can just pass in null. You can see it's the root element, the same thing we had when we came over here and went to a new layout resource file. We had to set the root element. We already set up our layout. We're not going to be building it or adjusting any code, so we don't need to worry about a root element here. And what did we have on there? We had 4 text views. Oh, we had 4 edit text. No text views. This is the output. Text view txt id. Import that. Equals list items dot find view by id r.id dot. So there should be something in there with the id txt id. And probably easiest just to copy that. So I put shift home. Select all that, 2, 3, 4. And I mentioned it before, but I'll say it again. It's a little counterintuitive, but it's actually more efficient to work down, copy it, make a bunch of copies, and then go down and adjust it instead of across. And I usually just double click to select the whole work. So txt age. Then double click here and override it with txt temp. And same thing over here. txt name, double click to select the whole little section, so txt age and txt town. And then all we want to do is put our data from this array we pass in into those text views. And we have an integer, so that's the integer is just going to walk through that array and put it in the text view and inflate that, throw it on the list. And it'll do that over and over and over again until it goes all the way through the list. So we have text ID dot set text, and we want to set that to the DB items index we're looking at dot get ID, and that is going to return an integer. So we need to cast that to a string. The easiest way to do that is just add the empty string beside it. Txt name, set text, and we're going to set it again, DB items, the index we're looking at, get name. That one's already a string, so we don't have to do any adjustments. Age we'll have to adjust the same way again, because that index, the get age method is going to return an integer, and we can just add an empty string to quickly cast that. And txt town dot set text, db items, the index we're looking at, get town, and that's going to return a string. And then finally we have to do what this method said it was going to do, which is return a view, now that we have one set up. So return list items. And that's all we need for the adapter. So why don't we go test that real quick. In the next video, I will render this down and then start a new segment of video to test it. Now, as you all are well aware, we don't want to wait till we get to the very end and just hope everything runs. So we're at a point we should be able to test this. So let's test the adapter and make sure it inflates into our list view. We can go ahead and set up a test case real quick. So if we come over to MainActivity, let's see, what will we need to do to test this? We'll need that list view, obviously. This view, LSD display data. Import that. And then to test it, well, I guess we just need an array to work with. So an array of DB items, I'll call it test, I'll go ahead and instantiate it this way. Just feed everything in, but I'm going to split it up to make it a little easier to read. So we need a new DB item. I'll just use the 3 constructor one. So Chris, age 41, lives in Clarksville. New DB item. Jennifer, age, oops, I don't need to type age. Age 37, lives in Jeffersonville. And new database item, Heather, age 40, lives in Salem. That'll give us a couple things to test with. Oh, whoops, those aren't supposed to be semicolons. I'll just split that up to make it easier to read. Those are supposed to be commas. Sorry about that. So that gives us an array of test items. So we can instantiate that list view. Find view by ID, r.id dot list display data. This display data dot set. Oh, we need the adapter first. What do I call it? DB adapter. I'll just take the default name is a new DB adapter. And we need to pass in a context and our array of data. So our context will be this, or to be more specific, the safe one is always to go with MainActivity.this, because then it knows to go to the MainActivity class and it'll figure out where it needs to be from there. In our case, we're still in the main thread of the MainActivity, so we'd be fine with just this, but the one we can use anywhere would be to the class name.this, and it'll figure out the rest of it. And then that array called test. So then our list display data dot set adapter to the DB adapter. So this should run and display on the screen. So I'm going to go ahead and run that and just hopefully this will work. And no need to watch the Gradle build running. So I'm going to pause the video and I'll be back in just a moment with either the app running or corrections for it. So all that worked, at least for the test. You can see those little ones I put there popped up. Let's get that out of the way. So there's some test data going up on the list view. So that's all of the stuff we've seen before. Now we're ready to get into the new stuff. Let's jump back over to Android Studio and look at the SQLite database stuff. So with a successful test, we can go ahead and comment out this test data. Oh, wait. Down here and push enter. And then Android Studio, put the closing comment in there. So the test was successful. As far as old stuff, we've seen all that before, right? Items, well, all our layouts and resources, a Java object just to organize our data, make it a little easier to work with, and an adapter to inflate our data into a layout and inflate that layout into the list view. The new stuff we're going to look at an SQLite database. So the primary object we need for that, again, the new Java class, we want it in the same package, so it's a good idea to right click on the package. If you right click somewhere else and just go to a Java class, make sure you type the package name in, that way you don't have to import it. And we need some sort of name. I'll call this DB helper. And the superclass needs to be SQLite Open Helper. Yeah, android.database.sqlite Open Helper is the one we want to extend. So you can see it's abstract. There's some methods to implement, but there are a couple things we need to set up first. And then we'll get started into the SQL stuff. So first off, when we create it, we need a name for our database. And because of the way this is set up, we'll need a version number. We'll see that in a moment. So we need these two fields that have to be static. I'll go ahead and make them constants. One of them is a string called DB name. And we can go ahead and instantiate that. What do I call this? I'll just call it example.db. That'll work. Just some name on there. And we also need a private static might as well make it final because we're not going to change it. Int called DB version. So we need a name and a version right off the bat. I'll just make it 1. And we'll need those for the constructor is what we need them for. If I come over here and try to generate the constructor, see there's a couple different versions. This is kind of like the one we're going to use. Any of them will work. I'm going to erase it in just a second. So you can see Android Studio generates it with the annotation style, error handling. Those are really useful. We don't have time in class to cover that, but something to maybe look up a little bit about when you have some time. We're not trying to learn a whole lot of stuff in 8 weeks' time. But you can see all the things passed in are just passed on to the super method. I'm going to retype it and make a slightly cleaner version. So public DB helper. And the only thing I want to pass in is the context. The activity or view or whatever we are connecting to it. In our case, the activity we're connecting to it. Just want to pass in the context. And then we're going to pass this on to the super. And we can see from the little predicting things, the ones we want. We'll take this, use this first one. So we need to pass in a context, which is why we took that in. Now when we write in the main activity, we can just ask for it and put this in the constructor. The name of the database, which is that thing we just created, so db underscore name. Oops, that's not what I called it. Name in all caps. A factory, which we're not getting into factories much here. It's an alternative to constructors for more dynamic things. So instead of using a constructor to instantiate an object that we keep around in memory for a while and modify as we need it, you can think of a factory as it just pumps out a whole bunch of disposable objects. One-time use things. It quickly generates the one we need, uses it, and then throws it away. And then does it again when we need it. Kind of like what a factory does. So in short, just an alternative to constructors, which we're not really getting into, and we don't need it for our example. It's more dynamic. So you would need a factory if you had a table tied directly to the database so that people could see the data changing in live time and stuff. Is why there's a factory there. And we also need the DB version. And this is why these have to be static. Because remember, static means there's only one copy. And if there's only one copy, we can get it in the blueprint for the objects instead of an instance of the object itself. Which in this case, we need this name and version in order to create any objects. So we have to have that around before we even create, in order to just create an instance of the object. So they need to be static. That way we can refer back to the class. Because if there's only one of them, if there's only one copy, which is what static means, then we can use the copy that's in the class and not a particular instance of the class. So that's kind of a setup there. A couple things we'll need are the names. Some names for the tables and columns that we're going to work with. So I'll go ahead and set those up while I'm up here at the top typing. So we need and those are all going to be strings because that's just the name of the field, not the data in the field. So private string, I'll just call it table. We only have one. I guess it wouldn't hurt to call it table 1, but for this example, we're just going to have one table. So I'm going to call that test table. Private string I'm in the habit of just writing column 1, column 2, column 3, but why don't I go ahead and give them more useful names here? So one called ID, that will be underscore ID. Private string name equals name. Private string age equals age. And again, our age data is an integer, but this is just the label for the field, the header text, maybe. And a private string town equal town. That might be a little less confusing than what I started typing earlier, because that way the names match up. I might as well make them match exactly. Make the code look a little bit cleaner, more like a regular SQL statement. But usually I just use the column numbers to indicate that. I found it useful in some different situations, which aren't really going to show up in this example. So some useful names are probably better. So strings, variable names matching our string names. Hopefully that's not too confusing. Well, maybe I shouldn't name them the exact same thing. I'll go back to what I'd originally thought. And whoops. And just use regular Java looking variables here to hold the SQL looking names here. So this underline tells us that this is either needs to be abstract or implement a couple methods. So we should need to implement those methods now. I'll insert, implement methods, and there's two that are required, onCreate and onUpgrade. I'm going to fill out the onUpgrade method first. And this one's basically always looks the same. You'll see we're passed into a couple objects, a SQL database and some integers. I'm going to change that reference to just DB. That's the way I like to type it. After I do that a few times, Android Studio will start predicting that, which is really, really useful. So all we need to do on the upgrade, well, whenever we access the database, it's automatically going to check our version number. And if the version number has changed since the last time it was used, it's going to run the onUpgrade. So what do we want to do when the version number changes? So what we want to do is that database was passed in, we want to execute a SQL statement on it. Execute SQL, which was mentioned in class earlier, and just to state it again here to be clear. SQL is a type of language. There are a whole lot of different SQL languages. We're using SQLite here, SQLite. So some of it may look familiar, but it may also look a little different than what you're used to. Because structured query language is a type of language. It's not an individual language on it by itself. So our query that we want to pass in if we've updated the database is, well, we want to drop table if exists plus our table name. So if when we update our app, a couple years after year or two after you make it, you might have some ideas to change things. You'll change the DB, this to version 2 of the database. And at that point, it'll drop the old table, and then we want to call the onCreate method and pass in the database. So there's different ways to look at it. Really, it's making a stack here, and it's going to do this with the information in the database and then drop it. A better way to think of it might be we're being passed in a copy of the database. So in the actual database, we're going to drop the table, and then we're going to take that copy and pass that copy back to the onCreate method. And notice that even though I started typing a string, since it was a SQL statement, it changed to this orange color instead of the normal green for a SQL statement. And I haven't had it on the light view in a minute, but I believe that shows up in white. And it looks like I'm coming on time on this video, so I'm going to render this down and be right back to fill out the onCreate method. So on upgrade, just to reiterate one more time, that runs whenever we change the database version number. So it's passing in these integers, it's going to check that. And if the version has changed, it's going to drop the table and recreate the database. And I need to render this video down, and I'll be back in just a second. Okay, so now the onCreate method. This is what's going to run whenever we first ask for the database and basically set it up for us for the first time. So what we want to do is, well, very first time we need to create our table so that we can add data to it. So we can put that in as a query. We'll create it as a string and pass it in. And create table. Some of this may look familiar. It may look slightly different than what you're used to, because SQL is a type of language. It's not a single language. There's a lot of different versions of a lot of different structured query languages. It's not just one. So for SQLite, I think this part's consistent. Create table. You see that in all of them. We don't want to create it every time, right? We don't want 1,000 of the same table going on. So we want to create table if not exists plus our table name up here. I have that saved. Plus an open parentheses. Plus, maybe I should put an example here to refer to, since we're breaking this up and creating it. Just a reminder of what it's going to look like. Create table, the name in parentheses, the field and type of data. The syntax might change from time to time. Fill out all those, and then a semicolon at the end of the thing. But we need to build that with our variables here, and in this long string, concatenated together. So I'm going to split this up across a couple lines so it looks a little better. So the next thing is the field we want. So the first one is the ID plus then a space, and that'll be an integer primary key auto increment. And auto increment is one that seems to look different in every one of our SQL languages. So with SQLite, we just smash the words together. Then a comma, plus our next field will be name, and that is going to be a text. So the light part is we don't have as many data types to work with. You're probably used to, whenever you have text data in your regular database class that everybody's had, you're probably used to using varchar and say how many characters you can put in there. There's also a couple of versions of text that are rarely used because they're less efficient. But the light part, we have less data types. So we have text, just the one type of text, and integers, which actually correspond to longs in Java. So they're 64-bit integers coming back from the database. So we'll want to be careful with that when we get them back. But there's fewer data types. We still have blobs and a few things. You can check a list of the data types available.
But for the most part, you're going to use integers and text. We don't have any floating point numbers here, but for that, the key term is real, R-E-A-L. We don't have any of those, but that's our floating point data. The next one we do have is the age column, which again is going to be an integer, a comma, a space, plus a town, plus, and town is going to be a string again. That finishes our create table query, so close the parentheses, then a semicolon for the SQL, and a semicolon for the Java. I'll go ahead and erase this. And that'll create our table. So then we just want to execute that query. So the database we're passed in. So db.execute SQL and execute this create table one. And notice that it changed from the normal green color of a string to this SQL color whenever we did that. So that'll create our table, but only if it doesn't already exist. That way we don't end up with lots and lots and lots of versions of the same table, because that gets a little confusing. So the next thing we want to think about is putting some data in that table. And everybody said in class said they've had the database class. You probably remember insert queries. They're kind of tedious. They're not that bad. Usually look like insert into whatever table the fields are going to insert into. So in our case, like name, age, town, values, then the values we're putting in. So maybe a name, an integer, and another string. It may look something like that. And we have to do that over and over again, kind of tedious, very repetitive, but computers are great for very repetitive stuff. So most every programming language already has something built in to do that with, an object that we can work with. So let's make a method for adding data. I'm just going to set it to return a Boolean, a true/false value, so that we'll know whether it worked or not. I'd like to work with Booleans here in just a second as we write the method. We'll talk about the standard that you'll see over and over again and have probably already seen. And I'll just call this add data. And we'll pass in one of those DB items we created. So the object to do all the ints to work with for SQLite is going to be a content values object. Oh, I'll just call it CV equals new content values. And then we can use what I always refer to as maps, the key value pair type data structure, to pass our data in. And then it'll handle all the tedious syntax for the insert queries. So CV dot, you can see the method here shows up everywhere as put. It's a key for this. There's always a string, and bytes, longs, booleans, integers, all the different types of data we have. So I'm going to call the put method, and let's see, our key needs to be a string, and that is the strings we created up here. So we gave our table these names, so it's going to look for those. Set that up with the insert query. So our first one is ID. Oh wait, we don't need to put the ID. The database handles the ID. we just needed that in the create table. So we just need to put the name one, and the value we want to put there is going to be that DB item we passed in, .get name. CV.put, the next one is the age column. So DB item.get age. Then we'll put in the town, DB item.get town. This is why I like to work with those items. That way we don't have separate lists, separate arrays, or a bunch of separate things working. We've just kind of consolidated it all into one object to work with. Now that sets all the stuff we want into that CV object. So now we need an instance of our database. So SQLite Database, I'm just going to call it DB equals, and we'll see over and over again this same line. So this dot get writable database. Well, either writable or readable. In this case, we want a writable database. Now that we have access to our database, we can go ahead and run this query. So I like to switch it to a Boolean. The standard, you might remember from working with databases before, whenever you insert the query, you'd always get that message, 0 rows affected, or 12 rows affected, or 50 rows affected, however many were changed. And that's been, whenever they first created databases, that was kind of the standard. Just the thing that made sense was to return how many rows are affected. I'll just call this result equals db dot, we want to run a raw query. And, no, not a raw query. We'll do that in a moment. We want to insert. So our first one is the table we're inserting into. We only have one table, but in bigger examples, you'd have those saved to variable names. We're not doing any column hacks, so I'm not going to modify anything about it. So pass null there. And then the content values object we want to pass in. So we have that set up. So it'll insert those queries and return the number of rows returned. So then we can just check that. So if result is equal to -1, well, that meant something bad happened. Oops. The result is equal to -1, something bad happened. So return false. It did not work. Else, go ahead and return true. Because even if it's a 0, everything froze up on me. Okay, there we go. Even if it's a 0 means the query did run. It just didn't insert for some reason. It might be, you might prefer to work with those numbers. I like to just see a true or false to know whether it worked or not. So that will insert a bunch of data into our database. And it looks like I'm coming on time to render down a video. So I'm going to render this down and be right back to do a select query. So reiterating, we have this content values object to work with where we can map our data to a string representing the name of the field in the table. And it will just go ahead and insert that for us. And when it does, it will return the number of rows inserted, which in this case is either going to be a -1, a 0, or a 1. And I just modified it to return true or false because of personal preference. And I'll render this video and be right back and we'll put together a method to grab all our data. Okay, some more board stuff real quick. The database. When we work with the database in a programming language,
you might wonder, what are we actually returning? And the thing we're returning, and it has a really good name in Android, we call it a cursor, which is kind of what it is. We return the thing that points at a row of data. It might seem a little confusing, so to visualize this, I like to think back to the earliest days of databases. You'll have probably seen in history books in the early days, the big tape machines have two big spools of tape. There are two big spools with some tape running between read and write heads, that sort of thing. So here's our, I'll just put the read head there. This is the only one that matters here. We have this tape running between these two spools and running past the read head, and that's where we grab the data and send it off from there. You'll have probably seen it in pictures in history books or something, and hopefully you're at least somewhat familiar with that. As the tape rolls past the read head, it's kind of split up. Maybe that little segment there, those little segments are a row of data. We have a whole bunch of those. So it spin, stop, read that row data, spin over to the next one, keep stopping, and just read the whole row of data at once. And kind of look to make those comparisons, any comparisons to decide if that was what it needed and return those parts of data. But basically the thing would look at an entire row. We could picture that looking at an entire row of our data at once. Then it spins over to look at the next row. The tape spins again to look at the next row. That's the thing we're returning. So we return the thing that looks at an entire row of data. That's what when we're working with the program database in a programming language, we're returning not really the row of data. We're returning the thing that looks at the row of data. Then we go through that, just like the old machine things, we go through the thing that's looking at the row of data and decide if that's the row of data we want or what parts of that row we want. Hopefully that's somewhat clear, because it can be a little confusing at first because we're not directly immediately returning our data. And yeah, so we're not returning the row of data, we're returning the thing that's looking at the row of data. And then we can look at that, and decide if that's the part we want or not. So let's go back over to Android Studio and write a method that returns all of our data and see how that goes together. Okay, now that we have a way to create our database and put at least one table in it and then insert some data, we're ready to set up a method to bring that data back to our app, and then we'll be ready to run another test, and hopefully everything's working at this point. So we need a method that will return an array of those DB items that we created. I'll call this get all data. Don't really need any parameters passed into it. Well, we don't know how much data is in there beforehand, so we need a dynamic structure initially. So an array list of these DB items, import that. And I like to set up an array list since it's dynamic and just fill that up with however many it is. And then afterwards, I'll convert that array list to a regular array of fixed size because it's a little more efficient to work with. We don't have all the dynamic stuff coming with it.
I'll just call that list is a new array list. And obviously we need an instance of our SQLite database to work with. db equals this.get writable database. I guess in this case a readable database would work. I usually use a writable database for everything. And well, we'll need a string to put together our query. So string, I'll just call it query, is, well, it should look kind of familiar from other SQL stuff. So we want to select everything from our table. And I'll just put where 1. That's a way of saying all conditions are met. Basically, everything's true. No matter what condition we put in, it's true. It's kind of like, almost like the wildcard selector for conditions. Now we need to run that. And when we run that query, it will return a cursor object. That's the thing we were just talking about on the board. So cursor, I'll just call it C equals db dot, and this time we want a raw query. So db dot raw query, and we're going to pass in our query. The first argument is a string, so the query we wrote. And we don't need any selection arguments. When they set this up, they kind of abbreviated it, so our conditions we could also put here if you are more comfortable doing it that way. Now, that'll bring back all of our data, every row of data. So we need to walk through that. So while c dot move to next, so move to next, it's just going to keep doing something, right? It's going to look at the first row, the second row, the third row, and eventually it's not going to be able to move to a next row. And whenever it can no longer move to the next row, then it will return false. So that's when our loop is done. But while it is moving through there, we need to grab the data that's in each row of our table. And we created these database item objects to organize it. So I'm going to instantiate one of those, db item, I'll just call it temp equals new db item. Actually, it might be better to do this afterwards. So I'll make our first one's an integer. So I'll make an int called temp ID. And that's going to equal c dot, you can see we have these get things. In particular, we want to get, well, it's an integer. So we'd like to get an integer. But SQLite, what SQLite calls an integer is a long to Java. So we actually want to get long, and then that's in column 0. So there's a long held in column 0. But we want that to be an integer because they're a little easier to work with in Java. And for our example, we know everything in there is going to be integers. You might find it easier to just work with a long. I mostly made that integers just to express that point, that what SQLite calls an integer is a 64-bit integer, which corresponds to a long in Java. So if you want to work with integers, you have to cast it back to an integer. The string we're fine with, so temp name is c.get string, and we know that in the second column has a string in it. It should be in the name. The third column is holding the age, so once again, we have that sizing issue to take into consideration. C.getLong, and that'll be in the third column, or index number 2. And finally, we have a string temp town is the cursor object dot get string, and we know that there's a string in the 4th column, or index number 3. Once we return all that, we can create a new DB item. I'll just call it temp is a new DB item with temp ID, temp name, temp age, and temp town. And then list.add temp. So it's just going to do that over and over again. It's going to get the ID, the name, the age, and the town from the row of data in our table, create one of those objects that we consolidated or organized our information in, and then put that on that dynamically sized list. So once we have our list filled up, eventually there's not going to be a next row it can move to, so it'll jump out of the while loop, and at that point we want to close everything in the opposite order of what we opened it in. So close the cursor object, then close the database. And then we can just, at that point, we'll know how many items we have, so we can make an array of fixed size. So I'll call that DB item. It's an array, I'll just call it return array. Is a new item DB array of DB items, and it is going to be list.size. Then we can call list.toArray, put the list into that array, and return array. That part at the end should look familiar just from Java. So that gives us a way to put a bunch of data in there and then get a bunch of data back, which is probably enough to start a test with. So if we go over to MainActivity, we can instantiate that stuff. So if we look back at our layout, it's been a minute since we looked at that. Well, okay. So we have 3 edit text and 2 buttons. So we can go ahead and instantiate those and then throw them on so the edit text are to enter more data and throw them up on that list view. And we know the adapter for the list view works because we already tested that. So we need private edit text. We had 3 of them, so text. No, we had 4. Oh, we have 3 to enter stuff in. We have name, text age, and text town. And import that. So we can set those up here. So txt name equals find view by ID, r.id.txt name, text age, find view by ID, r.id.txt age. We've seen this a few times. Find view by ID, r.id.txt town. And then we also had a couple buttons there. So private button, import that, and we had button add and button remove. go ahead and instantiate both of those. So button add is find view by ID, r.id.button add. And I like to just set the click listener right here next to where it's instantiated. I find it more organized, and make sure you type a capital O to get the IntelliSense to predict the right one for the new object. I'll go ahead and set up the other one. Just button remove, find view by ID, r.id.button remove, button remove, set on click listener to a new on click listener. And again, make sure you type a capital O. So, well, first we want to add the data to our list and then show it on the screen. And show it on the screen, we're going to do a lot. So I'm going to go ahead and make a method to just do that every time. It doesn't need to return anything, so void, I'll just call it fill list. So the first thing we need is an instance of our DB helper object. So DB helper, I'll just call that DB as a new DB helper. And remember, we need to pass in the context, so we can just go MainActivity.this. In most cases, we probably will be okay to just say this, but remember, this is the good MainActivity.this is a better fallback to use every time. Then from that, we can just call that method we just made db.getAllData, and that is going to return an array of DB items. So DB item, an array called, I'll just call it DB items equals db.getAllData. That method we just wrote. So that'll run, bring back an array. Then we can just put that onto our list view. So we'll probably copy from this. Well, actually, we'll copy the last two lines. I'll just type them out again. We'll create a DB adapter. I'll just take the suggested name as a new DB adapter. And it's going to take in those items, DB items. Oh, and the context. So MainActivity.this and DB items. Now we can use that adapter in our list view. Let's display data dot set adapter to DB adapter there. And I think I need to instantiate that. It's commented out down below, yeah. So list display data equals find view by ID r.id dot list display data. We typed that line in earlier, but for the test, it was commented out. So we just open the database, run that method to return an array of our database items, feed that into an adapter, and use that adapter to inflate the list view. So we might as well do that immediately. As soon as we open the app, go ahead and fill up the list with data for anything that's in there. But on the very first run, there's not going to be anything. So we'll need to use this add data button. So we can pass that into a DB item. So DB item, new item is a new DB item. And I'm going to kind of split this up to make it easier to read. So our first argument, if we look back at this real quick, we're going from this constructor is the one from the code to the database. And then the one with the ID is for the database back to the code, back to the Java. So we'll use this 3-arg constructor for sending the item. So we need the name, the age, and the string, and name, age, and town in that order. So our first one is the name, and we'll have that in the text name dot get text dot toString. The second one we get in the same way, except that we want an integer. So we need to parse an integer out of that string. Integer.parseInt, and then the text that is in the age to edit text. Get text toString. Oops, comma there. And then the third one is a string again, so we can just use the regular get text. We don't have to parse anything out of it. toString. So that'll create a new item. And once we have an item, we can call up our DB helper. I'll just call it DB helper. That's going to be a new DB helper. And we need to pass in the context. So MainActivity.this, which here we're in the onCreate method. So we're definitely in the main thread, so we'd be okay to just say this, but this is a good habit to be in, to refer to it that way. And then we can just, from that, DB helper dot add data, and add in that DB item we just made. What do I call it? New item. So that'll take whatever the user types in those edit text boxes and create a new DB item and pass that on to the database to add to the list. And at that point, we should be okay to call this method we wrote down here to just put all of our data on there every time we add one. So fill list. So that should bring us up to a test point. I'm going to go ahead and run this, and I'm going to go ahead and run this and see if it works. You don't need to watch the Gradle build, so I'm going to pause this, and I'll be right back with either the app running or corrections if a typo crept in here somewhere. Okay, so that ran. Before we look at that real quick on the screen, I wanted to point out this. Over here in the gutter on the right-hand side, we have this thing, Device File Explorer. If we click on that, that shows the device we're looking at. So under this tab, Data, and then Data again, there's a whole lot going on my tablet. I need to clean this out. I've done a lot of examples here, and I didn't clean it out after the spring semester. But somewhere down here, our package com.example.database example. Should have that on here. Here we go. com.example.database example. I think it's this one. If we expand that, there's this folder databases. You can see here is that database example thing, .db that we created. That's our database. If you want to, where you're messing around with this, you can download and kind of look at that. It's a special kind of file, but you can probably open it and get and text editor and get some information, kind of figure out, get some sense of what's going on in there. But we can see our database was created here. So I'm going to go over and show that running here in just a second. Okay, so it ran. I've already put one thing in here just to test while the video was paused. That way I wouldn't waste a bunch of time with it. But we can type another one in here. I'll come in the edit text. So maybe we can get that showing. So basically the other test data I used, entered that in there. And then when I click the add data button, which is kind of hard to do from the camera here, you can see it took what's in the text box, added that to our database. We can tell because of the number 2 showing there, the integer primary key ID identifier from the database, and the data is just kind of loaded in there. So just kind of a basic example, very rudimentary working with databases in Android. You can see there's a lot of steps. A couple more things. Hopefully this video is not getting too long. It seems like it's going on a while. It's already 2 o'clock and got another class to teach tomorrow, so I need to get some sleep at some point. But the last 2 things I would like to do is we have the remove data button. So go ahead and set that up to just empty the database. And the other one was a method to, I'd mentioned earlier, set it up so that when we click on an item, it'll go ahead and delete that from the database. So I want to set those up. Hopefully the video is not getting too long here. But let's go back over to Android Studio and set up those last 2 things. So we still have this other button to remove all the data from the database to activate, and then we would like to set up clicking on list items to empty things out of there. So let's set up those 2 methods. We'll need to come back over to our DB helper, our helper object, and set up the delete all method. We'll do that first. So public, I'm not even going to bother with the return this time. We'll be able to see if it deleted it or not when there's nothing showing on the screen. Delete all data. And like we saw earlier, we can set up a string, or we could just probably pass in it's a short one, so we'll just do it right in the database. Is this dot get writable database, so we can do stuff with it. Then db dot execute SQL, and the one we want to execute is delete from plus our table name plus that condition we saw earlier, where 1. So basically just go ahead and delete all condition. Delete everything is what that's saying. And then we close our database. Not a whole lot to that method. And we'll go over and implement it real quick. Actually, while we're here, why don't we go ahead and write the other delete methods, and then we'll just stay over in the other one. So again, we don't necessarily need to return anything. We'll we'll see that it's missing from the screen if it worked or not. This time, we'll need to pass in some sort of condition to test. So why don't we pass in a name? That'll work. Well, there's something called name, so I'll just pass in a string, and we'll check that against the name column. So this time I'm going to go ahead and write it out as a string. Our query is going to be delete from plus the table name plus where, and we can check the name column. Name equals that string we passed in. However, if you remember the conditions in SQL, I'll write it up here. The condition should look something like where name equals, well, my name's in there. Something like that. So we need those quote marks around that string we're passing in. So here, before we put it, we'll put a single apostrophe or an escape sequence, whichever one you prefer. I'll just use the single quote. And then afterwards, we want to put another single quote mark. And when you do that, watch carefully, because sometimes the predictive things will try to go ahead and put the closing one right next to it, and then you'll have some extra ones that'll throw an error. That's a problem that I've encountered quite a few times. Well, now we can run that. So we need a SQLite database, db equals this dot get writable database, and db dot execute SQL with that query we just wrote. Query. And then we want to close our database. So set up a couple of delete queries, one to just empty the whole database, and one when we click on an item on the list, we'll pass in the name field and it'll just empty that name field. That seemed a quick, easy way to do that. So if we go back, we can go over and write those. So the button remove, well, that just needs to call that method. So to call that, we'll need an instance of our DB helper, because that's where it's at. I'll just call it DB equals new DB helper. And we need to pass in the context. MainActivity.this is kind of the safe way to do that. Then we can call DB dot delete all data. And close the database. So we don't want to leave a connection to the database open. And then we'll fill the list back out. That way we can see that there's nothing running on that. We'll test that in a moment. If we were in the classroom, I'd go ahead and run that. But on the video, we can set up the other one, and then we'll test them both at the same time. Hopefully they'll work. So hopefully there's no typos here. It's getting starting to get a little late. You can probably see the little clock down here. But it should be an easy fix. This next method is a little more, there's a little more to it. We want to know if we clicked on an item. So like so many things we've seen in Android, it's already built for us. We just, whoops. No idea what that did. Okay, So LSD display data, and we can set on item click listener. That way, listen for a click on a particular item, and that is going to be new. We want adapter view dot on item click listener. So I've already selected this before. There's a couple in there. Make sure on the IntelliSense you select the adapter view dot on item click listener that does not have a generic. So the one with no angle brackets. So right here before the dot, you want to make sure there's no angle brackets there. There's also one with angle brackets. And then that kind of sets up like we've seen before. This little method, it overrides this method on item click that passes in the adapter view we used, the actual view we clicked on, and a couple integers. And the index from, basically the index from the adapter. So whatever index that is in our list, that's the one we'll use here. And then another, that item ID that we set up when we make an adapter. So it passes it in basically this index, the one we use when we inflate our list, and this identifier. We get both of those passed in. So as always, there's more than one way to do this. What I like to do, we have these DB items. I'll take that. So I'm going to cast something into that. And what I'm going to cast is on this list view, we have connected to the list view, we have a method get item at position. So LSD display data get item at position, and we're passed in this integer here. Yours might have a different name, and I've got mine set up to just call the integer index as I. So that's the index we clicked on. We're going to get whatever that item is and pass that in there. And then we set up that method to, well, we'll go back over and look at it. So we're going to call this delete record method and pass in the name field in order to delete it. So to do that, we need an instance of our DB helper. DB equals new DB helper. Again, we need the context, so MainActivity.this. Then we can call that method db.delete record, and we need to pass in the name field because that's how we set it up. Probably could have named that variable a little bit better, but we know we can get that from item.getName. So whatever item we click on, we're going to get the item at that position, cast it into one of our items, and then we can just call the item.getName method to do that. And that should delete that record. We can close our database and refill the list. So that should be everything unless a typo worked in there. I'm going to go ahead and run this, and I will be back in a second with either that working or corrections for any typos that might have worked in there, seeing as how it's getting late. Okay, so I think you all can figure out what it means if you see me in this next scene instead of some corrections there. Yeah, so the app, everything was working when I tested it. You might notice the IDs from the database have changed since the last one. And that's because this button worked. If I click the remove all data, it's hard to do from the camera. Come around here like this, click remove all data, and it's gone from the screen. Let me pause this and put some data back in there real quick. Okay, filled that back up after emptying it. You can see there's a couple things there. And if we click on one of the items, it deletes that item from the database. That was everything I was wanting to put in there. Just some very rudimentary, basic stuff to work with. Grab the data, or bring it back, throw it up on the screen. We have SQLite available in everything we do in Android, so it's a really good way to store data. Next week, we are going to look at content providers. So we will take the stuff that's in our database and share it with other apps. That's what content providers do. Also next week, we'll take a look at Google Maps, putting those in our activities. So I believe the homework was on that was scheduled for week 6 homework. You can push that back until after we've covered it in class. Then might as well finish out the agenda. We're also going to do a little exercise of looking at the reference material. I have a list of questions. I'll randomly distribute those in class, and you just have to point at the answer on the official API just to and show you know how to read those official documentation pages. We'll do that. Might have some, animations are in there somewhere. We'll do animations and add audio, video. Those are really easy, all really easy. And that's pretty much going to finish out the semester. We'll take a day to look at my Google Play account, and so you can see what it's like to load up all the data and stuff on there. I'll post the code with this video, and everything seemed to work. Just set up a database, so that we have persistent data. It lasts from run to run on the app without using things like shared preferences or mapping it to an intent where we just keep it bouncing around memory for a long time. Actually have some data in a proper storage format instead of that. If you have any questions, let me know. Otherwise, I will see you all next week.